This is specifically for the class that I'm missing on December 2nd, but obviously I will have it posted and anybody is welcome to watch it. This is on how to compare linear and exponential graphs, and we're going to do that with equations, with graphs, and with tables, and kind of want to be able to work between any of those three ways. So first off, we're going to talk about these three things. The initial value, the y-intercept, the starting point. Again, because it is a y-intercept, it's important to note, so please write this down, x equals 0. So if you're looking for the initial value, that's going to happen when x equals 0. So we might call that the starting point. And then both types of functions have this. The slope, rise over run, rate of change, just really briefly, if this is going up to the right, that's positive. Going down to the right, that's negative. If it's perfectly horizontal, that's a 0 slope. And if it's perfectly vertical, that is a slope that is undefined. So we use that U for undefined. And this is then slope man. So we might call that slope man. And then only linear functions have a constant slope. So keep that in mind. And then we have growth factor. This is a common ratio or a multiplier, and then only exponential functions have a constant growth factor. So this is exponential, and this is linear. And I'm going to abbreviate in that way. LIN for linear and EXP for exponential. Okay, so linear functions, these are their general form. You guys have seen this before. Y equals mx plus b, where m is the slope, the rise over the run. B is the initial value, the y-intercept, and there is no constant growth factor. And then for the exponential function equations, their general form is y equals a times b to the x power, where a is the initial value, the y-intercept, b is the growth factor, and there's no constant slope. So think about this. If x is 0, when x is equal to 0, you've got some number b raised to the 0 power. So if I have b to the 0 power, remember that that's equal to 1. So then I have what is 1 times a, so y equals a. Again, a would be the initial value or the y-intercept, and that happens when x equals 0. So they've given some examples here. Here, this is a linear. The slope is 1/5. So let's see if we just think here, there's y equals mx plus b. You can see that my slope is 1/5 and that my y-intercept b is 3. That's the initial value. That's the same as this, the y-intercept. And then the slope is 1/5. It has a slope, so this is a linear equation. This one down here, thing to keep in mind here is that there is no number here in front of x, which is the same as saying that that value is 1. So x is the same as 1x, the slope is 1, and that's a rise of 1 over a run of 1. So that's 1 over 1. The initial value is 7/5, and there you have it. So over on this side, we've got the slope, exponential equations. Here, let's look. The initial value here is -1/4. That comes from this part right here that does not have the variable with it. And then your growth factor, 2, is that part right there that does have the x with it. And so if you're raising x to the 0, if x is to the 0 power, you're raising 2 to the 0 power, that's 1. Once again, your initial value then is -1/4. So if you wanted to plot just that point, it would be the point 0, -1/4. And this is the y value, and when x is 0, that's what happens because 2 to the x, just if this is the 0 power, this all just becomes 1. And then 1 times negative 1/4, negative 1/4. All right. Keep in mind that your growth factor can be a fraction. So there's 1/2, and there we go. Let's go down and look at some examples. So I'm just going to do a couple. This one, I think the biggest thing you want to look for is that the variable is the exponent. If you have the equation, that means this is exponential. Your variable is an exponent, it's exponential. Its initial value would be negative 1/3, and the slope or growth factor then would be 2. This one, the variable is not an exponent, so this one is linear. If that's all we're comparing is those two, then that's linear. Its initial value is negative 5/3. They tried to trick us by giving us a fraction, but it's not. See, y equals mx plus b. The slope is what's with the x. Negative 5/3 is not by the x. 3 is. And so the slope is 3. Remember that that's the same as 3 over 1. That's the rise, and that's the run. So if all you have is a whole number, remember that you can divide anything by 1. All right. So this one would be linear, and this one would be exponential. I'll let you work through some of these just kind of on your own. All right, linear function graphs. It talks about what these look like. This line has a y-intercept of 0, 2. I'm going to go over that in red. So that is 0, 2. The initial value is 2. The line has 2 points. It has more points, but it has these points, 0, 2, and negative 3, negative 2. And it shows those points because they are at whole numbers. Both of these are whole number values. So it makes it easier to just kind of tell what the slope is. This one goes from this point, we'll call this point 1 here, to point 2. It goes up 1, 2, 3, 4. That's up 4. And then it runs 1, 2, 3, plus 3. And so the y's increase by 4 as the x's increase by 3. So the slope is 4/3. Now, if we wanted to write that equation, remember it's y equals mx plus b. So we have the slope, y equals 4/3 x, and the initial value is 2, so that's plus 2. All right. I'm going to let you do, or you can read this one on your own. Same basic idea. Let's take a look at the exponential functions. Now, I do think sometimes it's useful to kind of, it talks about where these points are. This is not a straight line. This is not a straight line, so it's not linear. You can see it's a curve, and if those are our two options, the curvy ones are the exponential, and the ones that are straight lines would be linear. So here, it talks about these 3 points. Notice again, these are whole number points. So here's 0, 3, 1, 6, and 2, 12. And it shows those points. I think it's useful to put those in a table just so you can analyze kind of what's happened. And this also will help you with the table part that will come next here. So I've got 0, 3, 1, 6, and 2, 12. And then I'm going to notice here that these x values increase by 1. And so over here, this is, I could say from 3 to 6, well, that's plus 3. And that would be the pattern if this is also plus 3. But 6 plus 3 is 9, not 12. So it's not linear. It's not a constant change. And so the other thing that we might try then, to go from 3 to 6, that would be times 2. So if I multiply by 2 here, then as you see if that applies down here, is 6 times 2, 12. It is. And so the growth factor is 2. And that's what it says here. This function is multiplying by 2. And then again, you can have your initial value be negative. That's what's happening here. You can go through these points and kind of show the same thing. I'll let you go through ahead, read that. It's not super hard. But if you were doing this equation, again, remember that's y equals a times b to the x. And so my initial value is a. Then I would just write y equals -4 times, and you can put this in parentheses. It says the growth factor is, well, the function is dividing by 2. Remember that dividing by 2 is the same as multiplying by its reciprocal. And since 2 is the same as 2 over 1, the reciprocal is 1 over 2. The reciprocal, you just switch places. So dividing by 2 is the same as multiplying by 1/2. And so it says, which means the growth factor is 1/2. So I would put 1/2 here raised to the power x. And what if you're like, man, I don't know if that's right or not. Remember, you can use a program like, let's say, Desmos. And I can type in here y equals -4. And then let's open up a set of parentheses times. And we said it was 1/2. So 1 divided by 2. And then let's open the parentheses. And then again, shift 6. That's squared. And, not squared, excuse me. Raised to the power x. There we go. And, hey, is that what that looks like? Notice that here, I'll just move that back a little bit. If I can get it right there. Yeah, almost. Okay. There you go. 1 -2. So is that what we had? One of the points was at 1 -2. There we go. Oh, by the way, this is -1. It says -1/8, but it should say -1 -8. So this should be negative here. All right. Determine what kind of function it is, linear or exponential, the initial value and the slope or the growth factor. So we can see this is curvy, so we can just go, all right, this is going to be exponential. What's its initial value? Well, right there, x equals 3. So that's the y-intercept. So the initial value is 3. The slope or the growth factor, well, keep in mind that when we're asking these things, it's either one or it's the other. And since this is exponential, it is a growth factor, not a slope. And so the growth factor here, if I go from this point, which is -1, 6, to the next point, 0, 3, looks like I'm probably dividing it by 2. Half of 6 would be 3. And let's just test that theory out here. If this is 3, half of that would be 3 halves, or 1.5. And so that point right there would be 1.5. And so you can go through that and kind of see that does apply. So this here, the growth factor is 1/2. And the equation for that would be y equals 3 times 1/2 raised to the power x. And that's what this exponential would look like. This one's linear. I think you guys got that. Remember, it's y equals mx plus b. I'm going to leave that one for you guys to do. Same thing with this one down here, number 2. Over here, the number 4, exponential. Let's take a look right here. This value would be -1/2. So this would, -1. here's negative 2, so that half of that's negative 1, and half of that would be negative 1/2. So this value, not x, y equals negative 1/2. So my initial value, negative 1/2. Obviously, again, this is exponential. It's got the curve to it, which means we're looking at a growth factor, not a slope. And what do I do to go from 1/2 to 1? So one way that you can do this is say, well, negative 1/2 times some number, we can just call it b, since that's what we've been using right here. No? Yeah, since we're using b here, let's just decide what's b. So I got negative 1/2 right there times some number b is equal to the next one here, negative 1. And so I want to get b alone. I want to convert this into 1. Since it's negative, I'm going to multiply it by negative. So I got negative 1/2 b is equal to negative 1. I'm going to multiply this by the reciprocal, negative 2. So negative times negative is positive, and then 2 times 1/2 is 1. So this is 1b, and the 1 is not necessary. I'm just going to erase the 1. But over here, I need to do the same thing. Again, multiply by negative 2. So negative 1 times negative 2 is a positive 2. My value of b is 2, which means my growth factor is 2. And this equation would look like y equals negative 1/2 times 2 raised to the power x. All right. Now on this next one, it talks about how the tables change. Tables show a constant slope. When the x increases by 1, the y's decrease by 10. The slope is negative 10. So here these increase. This is plus 1, plus 1, plus 1. Each one of those is increasing by 1. But down here, this is minus 10, minus 10, minus 10, minus 10. So if you have a constant change, meaning adding or subtracting, then that is going to be linear. But if you try to do that over here with the function, if you've got a table like this, and you're going plus 1, okay, on the x side, yeah, it's plus 1, plus 1, plus 1, plus 1. Each one of them increases by 1. But here, if you go, okay, well, this is plus 6, but 8 plus 6 is not 32. So like, well, that doesn't work. This would be plus something bigger than 6. So that's not constant. But so what you would say then is that what would I, maybe, since we have these two options, either linear or exponential, you might go, well, what would I multiply by 2? So that's times 4. Is 8 times 4 32? Yeah. And is 32 times 4 128? It is. You can check that in a calculator if you need to. And then 128 times 4 would be 512. Fantastic. So the initial value is here 32. Why? Because that is when x equals 0. But the growth factor is 4. Again, so if we were writing this down in the equation, we write y equals 32 times 4 raised to the power x. And then you would go from there. And you can check any one of the x values there. Put in 0, put in 1, put in negative 1, and you can just kind of check that. Again, if you need to, use your calculator. So I would encourage you to take a look at the rest of these here. Notice what why is this exponential? What is its initial value? What is the growth factor? How does that look? Remember, if the growth factor is a fraction, like 1/3, that's times 1/3, which means that each one is being divided by 3. That these are the same. Multiplying by 1/3 and dividing by 3, same thing. Remember that dividing by a number is the same as multiplying by its reciprocal, and vice versa. Okay, so determine what kind of function it is, linear or exponential. Well, these are all plus 1, plus 1, plus 1, plus 1. But this one, let's see, to go from -7 to -4, isn't that plus 3? And from -4 to -1, that's also plus 3. And that's plus 3. And that's plus 3. Therefore, this is linear. And its initial value is -1. Because that's when x equals 0. Your slope or your growth factor, you got to choose one. It's a slope because it's linear. It's not a growth factor. So slope is change in y over the change in x. That's 3 over 1 or just 3. Now, look at this one. Negative. Here, we look at this. This is a change of not plus 1, but this time it's plus 3 and plus 3 and plus 3. But over here, from -3 to 8, that would be plus 11. Is 8 plus 11 19? I think so. Plus 11. And then 19 plus 30, is that plus 11? Yes. Yes, it is. So, type. This is linear. They tried to throw us with this one. We got it. Linear. And then initial value. What's the initial value? 8. Because that's where x equals 0. And does this have a slope or growth factor? It does not have a growth factor because it's linear. It has a slope. And the slope is rise. That's the change in y's. That's 11 over the run, which is 3. So the slope is 11/3. And if we were to write this, y equals mx plus b, the slope is 11/3 times 11/3 times x plus 8. Alrighty. One more here. Let's look at this. This is another one where we've just got here plus 1, plus 1, plus 1, plus 1. And then 100 to 20. Well, you could try minus 80. But 20 minus 80 is not 4. 20 minus 80 would be -60. So that's not it. It's not minus. So how else could I get 100 from 100 to 20? I want to say divide by 5. And if I took 20 and divided by 5, would I get 4? Yes. Took 4 and divided by 5. Would I get 4/5? Yes. And if I took 4/5 and divided by 5, would I get 4/25? Yes, I would. So remember that divide by 5 is equal to multiply by 1/5. So the type, this is exponential. Its initial value is 20. Again, why? Because that's where x equals 0. And so yours doesn't have a slope because it's exponential, has a growth factor. And the growth factor is 1/5. So again, if I were to write this as equation, it'd be y equals my initial value, which is 20, times 1/5 raised to the power x. And there you have it. I know there's more here that I didn't go over. You've got this. Your assignment is a paper assignment, so please go through and you got this. We'll see you on Thursday.